3.4 covers solving multi-step inequalities. So our learning goals, I will write and solve multi-step inequalities and I will solve real-life problems. So you're probably noticing at this point that Chapter 3 really mirrors Chapter 1 quite a bit, where, we started with the addition, subtraction, inequalities in this case, then we went to multiplication, division, now we're on the multi-step. And it really, again, follows the same format as before. We follow the same rules as before. We just now have inequalities instead of equations. So to start off with, let's say we had this. We want to solve this and then graph the solution. 17 is less than or equal to 3y minus 4. Excuse me. So we're going to remember to keep that 3y together, just like we would if it were an equation, until there's nothing left on this side of our inequality, and then we can take care of the 3y. So my first step is going to be to add 4 to each side. I'm subtracting 4, so to solve that, I add 4. And I get 21 is less than or equal to 3y. And now I can just divide each side by 3 because 3 is a positive number. Nothing about my inequality changes. And I get 7 is less than or equal to y. Another way of writing that would be y is greater than or equal to 7. That might be a little easier to think about when you're graphing it on your number line. So I put out my number line, 2, 4, 6, 8. So 7 is going to be here. It's going to be a filled in circle because it's greater than or equal to. And we're talking about numbers that are greater than 7, so we're pointing toward positive infinity. So like I said, exactly the same as before. Just in this case, we have an inequality symbol instead of an equal sign. Now, sometimes we're going to get sometimes we're going to get inequalities that are a little strange, just like we did with equations. So, for example, 2, we are going to do 2 times 5x minus 3 is less than 10x plus 7. So in this case, you see I have the distributive property, I have variables on both sides, I have constants on both sides, so a couple of steps that I need to work through. My first step, like always, will be to distribute. It's green. So over here, I get 10x minus 6 is less than 10x plus 7. So a little weird looking. You notice you have a 10x on each side. But what I need to do is I need to go a step further. If I say subtract 10x from each side, then I'm left with negative 6 over here, and I'm left with a 7 over here. So what happens is I have negative 6 is less than 7. Before, when I got something strange like this, I'd say, well, there's no solution. But if you think about it, negative 6 is always less than 7. So if you get an inequality that's set up like this and you get something that's true, you're going to say your solution is all real numbers. And the way you can show that is an R, but you draw like 2 lines, call it double bar R. That shows you that all real numbers, so x can be anything. You could also say there are infinitely many solutions. That's another way of saying that. Now, we could also get a situation, remember before no solution was a possibility, that can be a possibility here as well. So for example, 3, if we had 8x minus 3, is greater than 4 times 2x plus 3. Again, we're going to distribute first. So 8x minus 3 is greater than 8x plus 12. If I wanted to simplify this, I'm going to subtract 8x from each side. Try and get the variables all together. So over here, I have 0 minus 3, which is negative 3, and that's greater than 12. Negative 3 is never greater than 12. That's not possible. So in this case, my answer would be no solution. So if you get an inequality that's true, your answer is all real numbers or infinitely many, which means you can put anything you want in for x and it will work. In this case, no matter what you put in for x, you'll never get something that's true. So we'd say no solution for that one.